Now that we have our basic timeline down, we're going to go ahead and jump into chapter 1. So for this week, we're going to be covering section 1.1 and 1.2. So let's get started with section 1.1. So in section 1.1, we're just doing, again, basic computations. So what I'm going to do in these videos is I'm not going to do all of the problems. I'm going to do one of each type, and then the other one of each type is going to be left for you to work out for practice, or you can look at my filled out notes. The idea is, again, we're just going to work one of each type. We're not going to do them all. So if we want to find the interest, we do have a formula for this. It's I equals PRT. So I is going to be a dollar amount of interest earned. Okay, P is the principal. So that's the amount that we start with. So again, that's in money. R is the rate. Okay, now usually rates are given to us as a percent, which we'll see in a minute. So we need to convert it to a decimal for our equation. The big idea in this course is that you're showing me you understand the equations. It's okay if you know how to do it on Excel, but if you don't have an equation written down or a timeline, you're not going to get full credit for any of the problems. And then for our T here, T is going to be, it represents time, and that's usually in years. But again, the big idea is we need to match the units for R. Okay, so whatever they are, they always need to match the units for R. So let's take a look at example 1. So here we have a sum is deposited. So a sum is deposited, so that means P is 400. On February 1st, and we're not told a year, so 400 would go here, into an account that pays 9%. That means our R is 9%, so when we convert that to a decimal, that'd be 0.09 per annum, so that means per year, so that's yearly. And we want to know how much interest have we accumulated on July 1st of the same year. So we put July 1st here. This is the unknown. So that tells us that T is going to be 5 months. But again, we want per annum, so we're going to convert that to years. So that'd be 5/12 of a year. So whenever we see a date and we get one date to the next date of the same month, we consider it 1 month, so 1/12 of a year, no matter how many days have passed. Okay, so when we plug this into our formula, we're going to get I equals, and then we have our PRT, so our P was 400, R was 0.09, and T was 5/12. So I'm just color coding just to try to show you how everything goes together. So when we plug this in, our final answer would be 15, and then we need to consider, well, 15 what? What are our units here, right? All of these are going to be story problems, so all of them are going to require an answer with the proper units. So here our units would be money, because we're finding I. And usually we round to the nearest penny, so you can leave it as 15, or you can do 15.00, because nearest penny would be 2 decimal places. So I just wanted to make sure we touch on that. Let's look at another example. Okay, so let's look at another one. So here we're going to find the amount. So that means that we're using S equals P times 1 plus RT. So P again here is going to be the principal, and that goes at the beginning of the timeline. And then R is the rate. Again, we're going to need to convert that to a decimal. T is again time. And then S is the amount that we're looking for. So it's the future value. Okay, so that's going to go down here like this. And then again, we're going to have T. So T can be in months. So we can have the beginning date, and then the end date like we did before, or we can just have whatever amount of time. It just depends on what we're given in the problem. All of them are going to be a little bit different. Let's look at example 3. $1,525 is borrowed, so that would go at the beginning, because that's our P. at 14% interest, so that's our R. It's 14%, so it'll be 0.14. And 9 months, so it's not given, so we're going to assume yearly. And then our T is 9 months. So I use M to denote months, so that would be 9 months up here, or 9/12ths of a year. And you can reduce that like the book does. You don't have to. I would just leave it alone. And then our S that we're looking for is going to be down here. So we're going to get S equals our P, 1525 times 1 plus, and then our R, 0.14 times T, 9/12. And when you plug this in a calculator, you want to make sure that you're using those parentheses. So calculator keystrokes are something that I do pretty often, just to make sure that we understand how to put this in a calculator. And I'll show you that here in a minute, but I would do 1525 and then parentheses. You don't need a time sign here, but you can put 1 plus 0.14, and then I do times 9/12, and then M parentheses. So you could do an extra set of parentheses here, but again, you don't have to do it. So let me show you how that would look. So I have my scientific calculator popped up here. So I'm going to do 1525 times 1 plus 0.14 times 9/12, and then I end parenthesis. What? Then we're going to multiply that by our 525. I thought I had that in there, apparently it disappeared. So we get 1685.1. But when we look at this, it doesn't end nicely, so we have 0.125, but we went around to the nearest penny. So that puts our final answer at 1,685.13. So again, we're looking to round to this digit. So we're looking at the 5. 5 tells us to round up, so that's why we have 13. And that would be our final answer. This is our S.